right. Good morning, everyone. Thanks for coming out. I know 10 o'clock is a little early in the morning to talk about scripting sometimes, but I appreciate you coming out and being here. I'm actually really excited to talk to you about today's topic. But before we get into that, just a couple of logistical things. First, as I hope you're aware, assignment 1 is due today. I've gotten some questions about the assignment. It seems like it's been going pretty smoothly for everyone. At least I hope it's been going smoothly for everyone, as far as I can tell. Office hours have finally been situated, so I wanted to make sure you're aware that office hours are running as of today. So if you want to go to office hours today, you can. It is going to be from 11:30 to 1 every day, Monday through Thursday in Hour 214. So that's actually right after class, right down the hall. So that's pretty convenient for you all. If you need to speak to the TAs, they'll be available Monday through Thursday, right down the hall in Hour 214. If you have questions about assignment 1, you can definitely go talk to them. Or, I mean, I'm around as well. You can talk to me after class, and I also do take appointments. So please, I would love to see you in my office sometime, chat to you about the homework assignments or anything at all, really. Please don't hesitate to come by if you need anything from me. I also wanted to talk to you about due dates and stuff like that. I know that the official due date for assignment 1 is today. Does it say midnight or something like that? Yeah, 11:59 p.m. So obviously, well, maybe not obviously, I don't know. I'm not going to be awake tonight at midnight, and you know, I'm also not a super big stickler on things like deadlines. They do matter for sure. Fortunately, nobody's asked me for an extension. I hope that means that everything's been going well. But if you find yourself in a tight spot, don't freak out too much. I definitely will accept assignments late in this class. That is usually not a problem for me at all. There are hard deadlines when I won't accept things anymore. I won't accept things, especially these first 5 assignments. I definitely won't accept once we've started the project, because that's just too late. We'll move on to the second phase of the class. But you know, there's really kind of 2 phases. If you get everything for the first half of the class into me by spring break or so, I'm not going to be too unhappy about it. I hope you're able to keep up with the due dates, right? I definitely don't recommend falling behind and trying to cram everything in the last week before spring break. That's certainly not the intention. I probably wouldn't be too happy if you did that, but I also don't want you to freak out if you have a bad week and you fall behind and you need a couple extra days on an assignment. No problem. Totally not a problem at all. You can confirm it with me if you want, but honestly, unless it's really late, I'm probably not even going to say anything. So just wanted to make you aware that the due date policy is pretty loosey-goosey in this class. Happy to talk to you about that if you have any questions or concerns about your specific situation. We're going to talk about assignment 2 at the end of class today. I want to talk to you about the scripting stuff first. Does anybody have any questions about assignment 1 or due dates or office hours or any of that fun stuff before we hop into today's topic? Any questions I can address off the bat? All right, great. Fantastic. Today's a really fun one. I tried to sell it to you on Monday, and it looks like it worked because a lot of you came today, so I appreciate that. Let's hop into one of my favorite topics in this class. Today we're going to be talking about scripting. So actually this builds off of what we talked about last class, and actually the class before, where we've just been learning various commands, right? Doing various command line stuff. And also we're going to be using Vim a lot today as well. Because what we're going to be doing with these scripts is taking a series of commands and then stringing them together to form, some overall big task, right? So the idea is that I'm not limited to just running one command at a time on the command line. I can put a whole bunch of commands together into a file. That file is called a script. And then I can run that script, and that gives me a lot more flexibility in terms of what I can do, how fast I can do stuff, et cetera, et cetera, et cetera. So it's like learning a new programming language in a sense, although a lot of what we're gonna be using are bash commands that we've already seen the last few days. Might introduce a few new ones today as well. Well, let's go ahead and get right into it. If you haven't already, definitely get your terminal up and running. I made a directory for today called scripting in my CSE237 directory. So if you're trying to keep things organized, you might want to make yourself a directory for today's topic of scripting. And I'm going to jump right into it and make a script file. And the way I'm going to do that is actually, I'm going to use Vim. Something that I didn't tell you about Vim last time is that if I try to open a file that doesn't exist, Vim will make it for me. So, I want to write a script, a brand new script. It's going to be the simplest script, a hello world script. Notice the file extension that I'm using here. I talked a little bit last time about how file extensions kind of matter, kind of don't, but they do matter. They do have a purpose. And for scripts, we're usually going to use the .sh extension on the end of the file. That tells us that it's a shell script, a series of commands expected to be run. Okay, so I hit that to start up Vim, and you'll notice that it's blank. This is a brand new file. It even tells me down at the bottom. This is a brand new file, right? That's why it's blank. I haven't done anything yet. All bash scripts are going to start the same way. They start at the very top with a directive. So I'm going to hit the I key to go into insert mode because I need to start typing some stuff. And to insert a directive, we say, oh, that's hard to see, isn't it, on the dark background? It's pound sign exclamation point, or hashtag exclamation point. Sorry that that's so difficult to see. After that, we're going to put the words bin bash, also hard to see. I wonder if I can change that somehow so that it's actually easier to see. I don't want to fiddle with that right now because it's going to be class time, but maybe when we take a break for our exercises, I'll see if I can figure out how to make that font a little easier to read on the screen. This is going to be at the top of every one of our scripts that we write today because this is what tells the computer, essentially, that what we're doing is a series of bash commands as opposed to text or Java code or Python or PDFs or whatever the case may be. This is a clear indication right off the bat that what we are about to tell you is a series of bash commands. So I'm going to put in, I actually need to put in comments, but you can put in comments with the hash by itself. Notice there's no exclamation point this time. And I'm going to start with the simplest command that we've seen. Right? This is a hello world program, so I'm just going to use echo, which is our version of print. Once I'm done, I need to save this and get out of Vim. How do I do that again? Can somebody help me out? How do I save this file and get out of here? Yeah. You are mostly correct. There's one other thing I got to do first. I got to get out of insert mode first, right? Because if you don't, you're gonna get the WQ on the end of my line. I've done that so many times, and you will too. That's just part of the deal, right? But yeah, gotta hit that escape key first. Then we can do our :WQ for write and quit. And if I run ls, these are the exercises. But then over here at the very end, there's the script that I wrote. Real quick, just want to check. Actually, with an additional flag on ls, the .-l flag shows me more information, and specifically I'm interested in this over here. What's that block of stuff again? On the very left-hand side. Those are the file permissions. If I want to use this script, it has to have execute permissions, the X has to be available. So because I said, .sh, this is a script, my computer automatically said, well, it better have the X flags on there. I'm assuming that that's probably what your machine did as well. However, sometimes it doesn't happen. Sometimes I make a mistake. Sometimes the computer doesn't behave in the way that I expect it to. So if necessary, we can fix this, right? Does anybody remember the command for modifying permissions? chmod is the command? Yeah, great. So if you need to, which you may not, but if you do need to, you can use chmod And a good series, a good set for us to use to make this executable would be something like 755. The 7 is for us, for the owner, which is you or me or whoever is the computer we're on. So that gives us free reign. We can do whatever we want with the file. And the 55 gives everybody else the ability to look at and run the file, but not actually modify it. Whoops. And then you can see that I jumped the gun a little bit. Got a little anxious there, forgot to put the name of the file afterwards that I'm changing the permissions for. I don't think that's really going to do anything for me, did it? No, I mean, yeah. I didn't need to do this in the first place, just wanted to show you that that is a thing that does sometimes need to happen. Now we need to run this. We actually need to run this script. So it might seem like the way to do that would be to type the name of the file, and you're close. Unfortunately, just kind of due to the way that the command line is set up, in order to run the command, we actually have to be a little bit more specific. So this isn't quite specific enough. We need to put a dot and a slash out in front of it, but we actually kind of know what these mean a little bit. Anybody remember what the dot means? You're right. The dot is the current directory. The slash means look in this directory, basically. So we're saying look in the current directory for a file called hello.sh and run that. You might be wondering, why didn't it do that, the first time when I did it without the dot slash? Well, think about it. All of the commands that we've been running are not in this folder, right? They're in the folder where all of the commands live. So when I type it out the first way, it's looking in the folder where all of the commands live, right? All of the normal commands live, and saying, I don't know what you're talking about, because that's not where it is. We wrote it, we made it. So we're trying to be a little bit more specific and say, don't look in that place where all of the commands live. Look here, right here, and run this file called hello.sh. And when you do that, you'll see that it does, exactly what we said. Not exciting, right? It's a hello world program. They're not meant to be exciting. They're meant to get you off the ground. We're going to do some more exciting stuff later. Any questions so far? Everybody with me so far, I hope? Didn't lose anybody yet? Great. Fantastic. Let's do some more stuff. I'm going to make another script called sum.sh. We're going to be writing lots of scripts today, making lots of files today, using lots of them today. It's good practice. So the next one I'm going to do is sum.sh, and I'm going to show you how to make variables and do arithmetic, although I would argue arithmetic doesn't, maybe some simple math is okay, but if you're trying to do lots of heavy number crunching, this really isn't the place for it. You'd be better off writing, Java or Python or R or whatever number crunching language is your preference of choice, right? Bash scripting is not really meant for heavy number crunching. Small number crunching, minor number crunching, not a problem, though. So let's talk about it. First thing we got to do, the very top of the file. Well, first I got to go into insert mode again, and I got to put that directive at the very top every time. So it's hashtag exclamation point /bin/bash. Which, by the way, if you're wondering, that folder that I was talking about earlier, I was saying this is where all the commands live. That's it right there, /bin. That's the folder where all the commands live. You can actually cd to /bin and see for yourself. Well, maybe I'll show you that a little bit later on. But that's where bash lives, that's where echo lives, that's where all the commands we've been using, cd, ls, that's where they live. That's where the computer knows to find them. Okay, once we get the directive in there, let's make a variable. And this is where bash scripting gets really, 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 really finicky, perhaps even more finicky than you are used to. I am being very intentional with the way that I type this out. Notice that the equal sign is directly next to the variable name. If you put a space, in between there, notice the color changes, and that means you're going to have a bad time. Don't ask me why. They require that equal sign to be directly next to the variable name when you are creating variables like this, but it is in fact a requirement, and the color change shows that effect. It's annoying. It's not my favorite thing about it, but it is what it is, so you got to be careful. Let's do some math. So I just want to add two numbers together. That's pretty straightforward, but actually in order to pull this off, we need to take this whole thing and wrap it in parentheses. Two sets, as a matter of fact. So you'll notice that got that whole thing wrapped in parentheses, and those parentheses are necessary whenever we're doing arithmetic, typically. So if you're ever doing addition, multiplication, and stuff like that in a script, those signs are necessary. However, I would say the majority of the time, the arithmetic that I'm doing in a script is like I++ kind of stuff, right? Not super complicated math. So it's going to be pretty simple, straightforward math. But once we compute that sum, we want to see what the value is. So I'll go down on the next line and put an echo statement. And here we also have to be a little bit careful. Might seem like you can just say the name of the variable, but actually after the variable gets declared and created, if I want to use it again, we have to put a, oh wow, that's even harder to read, isn't it? We have to put a $sign out. Well, it's not so bad. We have to put a $sign out in front of it. It's got to be a $sign out in front of the variable. Otherwise it won't be recognized. And you can see that again too by the way the color changes. I mean, if you want to try it without, you can see the error that you would get. But yeah, let's escape :WQ and see if we can get this one to work. Now, in order to run it again, I can't say sum.sh, but I can say /sum.sh, and then it happily does the arithmetic for me and prints out the results. Any questions on that one? Okay, a couple more topics to show you before we do our first round of exercises for the day. For the next one, let's talk about how we can actually run commands. So when I say run commands, I should maybe be a little bit more specific. A lot of the commands that I'm going to be running, I need to somehow capture those commands, right, and use them in my script. So if I use ls, for example, I actually want to see the output of ls and use it in my script. Or if I use grep, for example, to search a file, I want to capture the output of grep and use that in my script to do more work, right, to do some other stuff. So how can we do that? How can I actually use those commands and get the results from those commands and further process them within my script? For that, we will go ahead and, whoops, hit the I key to go into insert, put in our directive at the very top. I'm going to make a variable. I want to mention too, actually, I've been making my variables all caps. That's sort of a convention. It's not required. You can definitely use lowercase variables. However, it's definitely considered convention, common practice to make it all caps. It does help the variables stand out a bit more in the code, which is part of the reason why it's done that way. Let's say I just want to grab ls, right, and see the contents of ls. $sign followed by parentheses, and then whatever command you want to use goes inside of those parentheses. What that will do is it will take ls, take the output of ls, which is just going to be a list of all the files, and it will store it in that variable. So it will take that list of files that it got back from ls, and it will store that list of files inside of that variable. And from there, I can do whatever I want to do with that information. Maybe I want to manipulate each one of those files in a particular way. Maybe I want to add a line to the end of each one of those files. It does something, right? We can use redirect commands for that. That's all stuff that can be done. But just to kind of do the simplest thing, we can, come down here and echo the output. What did I forget? $sign, good. Yeah, $sign. I do forget that $sign, genuine. That time was kind of on purpose, but I do genuinely forget the $sign quite a bit. It's new, it's different. Let's escape :WQ. And now we want to run that. It will be ./commands.sh. Oh, there we go. There's my result from ls, and actually we can run ls and see. Oh yes, it looks very similar, right? I don't get the color highlighting. That's okay. It's not really the point. The point is that we read this into a variable within our script. And then from there, we can take that variable and do whatever else we want to with it. And you can do that with any command, right? So if I come back up to vim commands, let's say I want to see a bit more than that. Let's say I want to see ls-l. That's fine. Any command that I want to. Let's say I want to pipe things together, right? That's okay too. Any command you can think of can go inside of these parentheses, and you can then capture the output of that and use it within your script. It's a very, 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 very powerful technique. One that you will need to use on the upcoming homework assignment for sure. So there's what it looks like, right? A little sloppy, but you can think of, well, if I'm just using this in a script, then what am I going to do? I'm probably going to use grep to search this for something, or use string parsing to parse out a particular piece of information that I want, right? It doesn't have to look good to do that. It doesn't have to look nice to do that. It's not really the point. One last thing before we get into our exercises, let's talk about how to do input, how to do user input. I'm going to make one more script called input.sh. So this would be the equivalent of doing like a scanner in Java, right? I don't remember I think it's just input on Python, but it's been a while, so I don't actually remember off the top of my head. But for doing it in the bash script, we're gonna, first tell them to do something. So this is just a prompt. And then we'll use the read command, where actually I kind of want to make this all caps. That's a variable name. So the read command will take whatever gets typed in on the keyboard and stash it in that variable. So I can call that whatever I want. Decide to call it name, since I asked the person to type in what their name is. And then if I want to print out like a hello message, I can do it like this. Notice too, with the way that I printed out this variable name, you can see how concatenation works, or really we don't have to do much to do concatenation, right? I can actually just plug that variable right inside of the string, and as we're about to see, it's smart enough to figure it out, do all the substitution for us without having to worry about plus signs or any of that stuff to actually do the concatenation altogether. But let's go ahead and escape :WQ to get out of Vim and try to run our input script. It should ask us to type in our name, so I'll type in my name, and then it says hi to me. Perfect. Perfect. Hopefully you were also successful. But if not, that's okay, because now's time for our first exercise. So I'm going to give you a little scripting exercise to do. Talk to your neighbors, flag me down for questions if you had problems with any of the examples. I would also be happy to talk to you about that. Make sure everything's up and running for you okay. Let me go ahead and show you what the first exercise for today is. All right. I want you to create a script that's going to ask the user the name of a directory they want to create. I want you to, actually I kind of skipped a step between 1 and 2, didn't I? You actually have to make the directory, so I kind of skipped a step. Then you have to go into that directory, print out the path of the directory. So I'm asking you to remember some commands. Some of these we haven't talked about since like the first day of class. You might need to do a little bit of Googling or refreshing of your memory. It's totally okay. I forget these commands all the time too. And then goes back to the original directory and deletes the directory that was created. The interesting thing about this script is that if everything works properly and you do it properly, right, after you run it, it'll look like nothing really. folder never existed in the first place. But it did. It just existed for a fraction of a second. You basically say, yeah, I'm here. I made the folder and I'm here. And then you delete all evidence. So take a few minutes, talk to your neighbors, let me know if you need any help, and I'll go through the solution at 10:30 something. Okay. I definitely saw people making progress on this one. If you got stuck along the way or didn't quite get it finished, that's totally fine. Let's talk about it. Probably multiple different ways to pull this off too. So if you found a different solution than what I'm about to show, then great. I'm going to start by just making the basics, right? I'm going to make an exercise 1 script called e1.sh. I'm going to put the directive up at the top, just like we've done for all of them. And the first thing it wants us to do is to ask them to type in the name of a directory we wish to create. So we'll use the echo command, right? And tell them what to type in. After we give them that prompt, we'll use the read command, right? Followed by some variable name to get the name of that directory from the user. And here's where things get kind of fun and interesting, at least in my opinion. We need to create that directory, so we're going to use the make directory command, but we're going to feed in the variable, right? So I can take that variable that I read in from the user and I can feed it into the make directory command, and now that will make the directory. It then asked us to navigate into the directory. So to do that one, we can just do cd and then kind of the same deal, where I can say the variable name afterwards, cd into this directory. For printing the path, does anybody remember what the command is that prints out the path? pwd, yeah, we talked about that one, I believe, on the first day of class or so. It's been a little while, but pwd will get the job done. So just say run pwd. Finally, it wants us to go out of the directory. So I need to leave this directory. So I use cd. How do I get out of this directory? How do I leave? Dot dot. Yeah, dot dot I think is probably the simplest, most straightforward way to do it. That'll take us back to where we started. I think that's another important thing to keep in mind, and something that will affect you on assignment 2 as well. I'm not running all of these commands in the same place, right? So if I'm trying to access a file or something in my script, I might need to cd into a different directory to be able to access that file. And then once I access that file, I may need to cd back out of that directory to get to where I used to be, right? So it's very important as you're writing these scripts to always keep in mind, where am I? Because if you forget to cd dot dot out of the directory, then you could end up throwing the whole thing off whack, looking for files in places they don't exist, and things like that. Definitely has happened to me, and I would imagine will probably happen to some of you on the upcoming assignment as well. It's a pretty classic bash scripting trap to fall into. Kind of why I'm trying to warn you about it now. But to wrap up this exercise, we're just going to remove the directory. You could have also used the rm command here. I think that's totally fine. I think either one will do the trick. And now we can escape :WQ to get back and try to run this. All right, I'll call it test. So kind of the reason why I like this example is that just by seeing this, right, we have proof. This is visual proof that the directory was created, it existed, we were actually in it, right? And then we said, here we are. We kind of planted the flag and said, this is us, this is where we're at. And then even though that's true, if I look now, the script deleted all trace afterwards, right? If you don't like that, you can certainly go in and take out the remove directory command at the end, and you'll see that, okay, yeah, it does exactly what you would expect it to. Still leaves it in place, right? I think also what's interesting, let me show you this final little piece before I move on to kind of show you what I was getting at before. If I'm going to remove the remove directory line, what command did I just use to remove that line in Embed? Anybody remember how you get rid of a line real quickly in Embed? dd. dd is the command. I don't even think about it anymore. It's been burned into my brain. I'm just like, that, I want that line out, dd. I want to do the same thing for this one. I'm going to actually take out the last 2 lines and show you what will happen, right? Let's think about it. I'm going to escape colon WQ, and when I run it this time, take a peek at what happens when I say, all right, make a test directory. Oh, there we are, right? We actually did cd into the test directory, but when the script stopped, we ended up where we originally started from. So it can be very confusing, where you're at when you're scripting. I guess is kind of the point I'm trying to make. But knowing that information is so important. Always try to keep track of, a little mental map in your head of what directory you're in your scripts. Leave yourself comments if you need to, so that you don't get lost. You don't end up in a place where you're not supposed to be. All right, let's talk about some new stuff. We're going to do kind of the standard programming constructs, but in a little bit of a different way, I think, than perhaps you're used to. We're going to start by doing loops. We're going to do for loops. So I'm going to make a script called loop. I'm going to do a couple examples with loops. So I'm going to call this one loop 1. So I've got at least one more example with a loop that I want to do as well. I'm going to start going faster through this part. So there goes the directive at the top. No surprise there. And I want to make a simple for loop. If you're used to Java, like we teach in 131, the classic for loop would be for int I equals 0, I less than 10, I plus plus. What that looks like in Bash is this. For counter, or I guess if you wanted to, maybe it would be cool to call this I, right? For I in curly brace 1 dot dot 10. Now be careful. The fact that there are only 2 dots there is significant, right? One will not do. 3 is too many. It has to be exactly 2. Otherwise, this is going to kind of work the way that you expect it to. The first time through the loop, I will be 1. The second time through the loop, I will be 2. So this is really the name of my loop variable right here. And I can call this whatever I want. I've just chosen to call it I in this particular situation. Now, you'll notice that we use the curly brackets for the range. So, using them again here is probably actually not what's going to happen, because we already used the curly brackets for something else. Instead of using curly brackets to say what's in our loop, we actually use words. So I say do, that's our open curly brace. I put the body of the loop in here, echo $I, and then my closing curly brace is the word done. So let's give this a try. Save and quit out of here. Let's see if we can get this to go. Beautiful. And then, of course, if you are interested in, changing the range, you just have to manipulate the values that are here. But it is going to count up by 1, right? Notice it's not super easy to manipulate. I would argue that, that's not really what bash scripting is for. I think you probably can do it if you want to. In fact, I know you can. But if you have to do weird series of things, then you probably should not be doing bash scripting, in my opinion. It's not really what it's for. But for these simple kinds of loops where you're just counting up by 1, it's actually, I would argue, simpler, more straightforward than you would find in Java. It is a bit more Python-like, actually, in that regard, which is kind of nice. Let's talk about a different kind of loop. One that actually, I would argue this next kind of loop that I'm going to show you is more common in bash scripting than the one that we just did. In fact, I'd be willing to bet that you might need a loop like this or a similar one on the upcoming assignment. One that instead of going through, Got to put the directive in first. Almost forgot. /bin/bash. So instead of writing a loop that's going to count, a loop variable 1 through 10 or whatever, we're going to loop through a list of items instead. So I think there's a few different ways you can do that. I can, literally specify a list of items as a string. Or I think what might be perhaps more interesting is if I bring back something we've already talked about, right? For every item that I get from the result of calling the ls command, right? Now I can write a loop that's going to go through the results that I get back from the command one at a time. I hope you can kind of see how useful it would be to do something like that. Let me finish this example and show you how it will actually work. Again, our opening bracket is do. I'll just say echo the line, and then done is our closing bracket. And when we run this program, if I did it properly, oh, whoops, I didn't type the name of it in properly. It's loop 2. There we go. Yeah. Okay. Maybe not quite what I was going for. You'll notice that it didn't print it out line by line. It's actually printing it out word by word. Not exactly what I intended, but also, it still kind of gets my point across, right? Could I print it out line by line? I'm almost positive that there is a way. Do I know it off the top of my head? Not exactly, but with a little bit of Googling, I'm pretty confident that I can figure it out, right? I'm not worried about getting that too into the details today. The big thing that I'm trying to show you here, the power that I'm trying to show you here is that I can now take these commands and combine them with for loops. That's cool. That's very powerful. And our next topic may not be that much of a surprise to you either. We can also bring if statements into the equation as well. I'll show you two different kinds of if statements. One for using arithmetic, which again I would argue is kind of the lesser used one. But it's still good to know about. Here we go. I'll say enter a number. And notice that the read command actually doesn't care if I am asking for a string versus a number or anything like that. In Java, if I'm using scanner, I have to be specific. Read in an int, read in a string, read in a double. Here, it doesn't actually matter. It's just like read in whatever and stick it in this variable. So I'll call it n. Right? Ask the user to type in a number. I'm going to call that number n. And we're going to do something that's perhaps not particularly interesting, but what I'm more interested in is showing you the syntax. There's those parentheses again, right? Remember, anytime we're doing stuff with arithmetic, anytime we're doing stuff with numbers, those double parentheses are required to sort of tell Bash that, hey, we're not running these like commands. This is meant to be math. This is meant to be arithmetic. So if I want to, I can say, all right, if n is less than 0, you can kind of tell where I'm probably going with this one. Let's talk about the curly braces. The opening curly brace for this one is then. And I'll just say negative. L if. If it is, greater than 0, then echo positive. And then finally I can say else, which does exactly what you think it does, echo 0. And then to kind of end the if statement as a whole, so our closing curly brace, basically, is the word phi, or the word if reversed, right? That's how we close out the if statement as a whole. So here, I wanted to show you a structure that had all three of the if statement constructs in it. We got the if, followed by a condition to evaluate, numeric value, an else if, which is an abbreviated, right? Elif, and then finally an else statement. Let's try this out. Save and quit this and run this guy. Wants us to enter a number. I'll start with a positive one. Oops, uh-oh, I did something wrong. What did I do? Syntax error. I think I know what I did wrong, actually. And maybe you did the same wrong thing that I did. Or maybe you didn't. I see what I did. Oh boy, is it a fun one. In Bash, these parentheses. So everything in Bash is a command. And earlier, I was actually not explaining what the parentheses are entirely correctly. I was saying parentheses are included in Bash. These aren't commands about to do math. Actually, the parentheses themselves are commands in Bash, which I know is kind of strange and meta and a little weird to think about, but it's true. And I think the reason why it's unhappy with me is that I need to actually close out those with the semicolon. This looks strange, right? If you did this in Java, it would not be right. It would be very wrong. Yes? Oh, did I not have the dollar? Oh, do I need to take the dollar sign out? I'll try it that way next. Let me see if the semicolons fix it first. Oh, the semicolons didn't fix it? Okay. Let me try your suggestion then. Maybe you are correct. I've certainly been wrong before. Oh, in the first one. Oh my gosh. Okay. I see. Maybe I had two mistakes then. I'm curious if I need these semicolons or not. I'm going to take one out and see if it makes a difference. Ah, so I don't need the semicolons. All right, I was making stuff up then. Sorry about that. It's interesting, though, that the semicolons don't appear to hurt anything, right? I included it on one and not on the other one, and it's like, I'll take it or leave it. It's a little strange. Cool. Thank you for helping me fix that problem. I appreciate it. Let's try a negative value. Yeah, perfect. Good. So it is working. Awesome. And 0 works as well. So just to kind of wrap this one up, I know I got a little off track there with my error. I had the $sign with the read command. That was my mistake. I think that was the only mistake that I made. I think I had everything else good. And then I made it worse before I made it better. That's programming. That's how it goes sometimes. Let's take a look at one more if statement example, and then I'm going to turn you loose on another exercise. This time, as you might expect, we're going to use if statements to do string comparison, which I would, again, argue is vastly more useful for what we're doing bash scripting than the numeric example that I showed you. So, you know, let's take a look at a quick example. First, I'll start off by asking them to enter their name again, right? Simple enough. I'll read it in to a variable called name. And if, notice I'm not using parentheses this time because parentheses are for numeric things. I'm doing string comparison this time, so I'm going to use brackets. So I'll say if the name is equal to, you know, my name. You can use your name if you want to instead, because I'm going to say, you know, echo hello, else echo who are you? Act like I don't know who you are. I think one thing to maybe note, maybe you've seen this, maybe you haven't, if you take that space out, I think that can cause some problems sometimes between the brackets. Bash does have some quirks like that. Let's try this and see. If I type in my name, it says hi to me. If I type in literally anything else, then it says, who are you? Right? And I believe it is in fact case sensitive, so if I don't capitalize, right, it still doesn't know who I am. If that's not what you want, I'm sure there are ways to get around it. A little bit of Googling will probably get you there. The big takeaway, though, really is Arithmetic, parentheses, anything else basically, square brackets. If there aren't any questions, then let's do another exercise with this stuff. Your exercise is to write a script. It'll ask the user to type in 10 numbers and then compute the sum of all that are greater than 5. I'm asking you to do arithmetic here, even though I've been saying the string processing step is more important. I promise we'll get practice doing that too. But this one does have a lot of arithmetic involved, so keep that in mind when writing your loops and your if statements, more than your loops, I should say. But you'll need both. You'll need at least a loop and an if statement to get this done, I believe. Take a few minutes, talk to your neighbors if you would like, and I'll go through the solution in 5 or 10. I know I didn't give you a ton of time on this one, but actually the solution is not super long, and I also want to make sure that that I have enough time to get through the last few examples and chat with you about the homework assignment before you go. So I am going to start going through this one. I'm going to start by making my exercise 2 script, tacking that directive at the top. It's asking us to ask the user to type in 10 numbers, and then any of those numbers that are greater than 5, I want to compute the sum of those. I would hope that, if you are fresh out of 131, for example, you could think about how you would do this with for loops and if statements and realize that, well, it's the same process, right? I'm just using the Bash way of saying things instead of the Java way of saying things or the Python way of saying things or whatever language you're most comfortable with. It's going to be basically the same process. We just got to substitute the Java commands for the Bash commands. So, if I were doing this in Java or any language, the first thing I would think is I need a variable to keep track of what my sum is. I need a variable to track that, and I'd probably call it sum. And I'd probably set it to be 0 to start with, right? Because I haven't read any numbers in yet. So, all right, let's start that at 0. And now I can write my loop that's going to run for 10 times. I actually showed you that exact loop a little bit earlier on today. So it looks something like this. Our opening curly braces do, and then I kind of like to come in and just type done at the very beginning so that I have my beginning and end, and then I can fill in the middle, and I don't forget to put it. I don't forget to put it at the end because unlike Eclipse, it's not going to put that extra bracket in for me. I have to do that myself. All right, we now need to read in a value. So actually, I should probably prompt the user to type in a number first, and then read it in. Call it n, that's fine. And now we need to check to see if this value is in fact greater than 5. So we'll use an if statement, and because we're doing arithmetic and is a number, then I'm going to use the double parentheses to see if n is greater than 5. Not brackets. I almost used brackets. Not supposed to do that. Then I want to add sum to n. And I believe this needs double parentheses around it as well, since we're doing arithmetic there. And I believe, actually, I probably need dollar signs out in front of these too to make sure that I'm referencing the variables. I believe that because the variable you're assigning to does not need a dollar sign. Yeah, it's only when you're using the variable. It's a good question, though, and a good thing to note, a good thing to observe. Yeah, that was intentional. Notice how it's blue, like when I declared it up top. I think that's a sign that it's working okay. Although you can tell that I'm not like 100% confident. I think it's very possible that I screwed something up in here. But let's finish it up, and then we'll test it and fix any mistakes that I made. First, I'm going to close out the if statement. The loop's already closed out, so I suppose all I really need to do now is just print out the sum at the very end. Let's try it, see if it works. Oh, it's e2.sh. There we go. Type in a number. All right. So I need to keep these numbers simple. I'll type in 10, and then, less than 5, less than 5, 10, less than 5, less than 5, 10, less than 5, less than 5, 10. 1, 2, 3, 4. Yeah, 40. Perfect. I think it worked. I got it. I can put it up here real quick in case you wanted to take one last peek at my solution. Otherwise, I've got 3 more examples for you, and then we're going to chat about the homework to wrap things up for today. Our next script is going to deal with arguments. So what are arguments again? Somebody tell me what an argument is? It's been a little while. We have chatted about it. I've actually been using arguments today, kind of. If I say echo hello, right? Then that thing, hello, that's my argument. So anything that I'm feeding into the command, right? Not the flags. The flags start with a dash, and those are a little different. They just change the behavior a little bit. if I'm actually putting information into the command like this, then that's what's known as an argument. CD, right? CD is followed by an argument, where the argument represents the directory where I want to go. So lots of commands use arguments, and we can actually use arguments with our scripts as well. So I can have our scripts take in information when the script is begun, so that I can have my script respond to that information in some way. This is something that is very common. So let's make, I'm going to call it args. Slap my directive at the top, as usual. And there are a couple of predefined variables in Bash that are used to help you access the arguments. They're called global variables. And so really this script is going to be pretty simple. I'm going to say total arguments followed by $hashtag. This $hashtag, that is a global variable. It is automatically set to be the number of arguments. So when I type in the name of this script, if I type one word after it, that'll be 1. If I type 2 words after it, that'll be 2. If I don't type any after it, then it'll be 0, right? It just automatically gets set to however many words get typed, however many arguments get typed after the command when it's being executed. And then if I want to, I can also access those arguments. So the way that I can do that is I can say, whoops, my PC is at risk apparently. I can say hello, $1 will get me the value of the first argument, the first word. $2 would get me access to the second argument, or the second word. $3, and so on and so forth. And this is it. This is the whole script. There's actually not a whole lot of other things that I have to say about arguments, but let's try it out. If I run it with an argument, so I typed my name afterwards, right? Typed my name afterwards. It'll say total arguments 1, and then it says hello to me. Right? I could also run it again and put, my daughter's name as well. So now I have 2 arguments, right? But actually, I never do anything with the second one. I mean, it's not hurting anything, but it's gonna get ignored, right? It tells me I have 2, but I still don't. It doesn't do anything. Or what if I run it without any arguments? That's another thing that's interesting to think about. Total argument 0, and then it says hello to the void, a ghost, whatever you think, right? So can lead to problems if you're not prepared for, the situation when they don't give you the number of arguments that you expect. That is something that's important to keep in mind. The next one that I want to talk to you about is one that's going to come in very handy when working on the next homework assignment. I want to discuss existence, whether files exist, whether directories exist. I'm basically asking the question, does this file exist? And I want to get a yes or no answer back. Does this directory exist? I want to get a yes or no answer back. So let's write a little script that can help us with that. Here's our directive up at the top. I'm going to ask the user to enter the name of a file or directory. So I'm going to ask them to type it in. I'll stash it in a variable called name. And now I'm going to do some comparisons using if statements. Notice I'm not doing arithmetic here. This is definitely much more in the string comparison category. So we've got our square brackets this time, not the parentheses. And I'm going to use a special flag as well. The -d flag will check to see if a directory exists with this name. So whatever name I type in, this if statement will be true if a directory exists with that name. If it doesn't, then that will be false. And I can do with that information whatever I want to. For this simple example, I'm just going to say directory, right? Just say, hey, you found it. Oh, I forgot something though, didn't I? I forgot the then. I'm going to put an elif here. I'm going to use square brackets again, but this time instead of dash D, I'm going to say dash F. So it's the same thing, but with a file. Now I'm asking, does this thing exist as a file? Not a directory, but as a file. If the answer is true, then I do whatever's in this if statement. So it's going to tell me yes or no. I'll say echo file. And if it's not a directory and it's not a file, then it doesn't exist, right? So that's our else condition. Oops, not if. It needs to say phi at the end. Sorry about that. All right, that's going to do it for this script. So I'm going to escape WQ. And so actually, that's nice that I have my test directory from before, so I can use that to check this. I have that from the previous exercise. I'm going to try this a few different ways. I'll try to type in one of these files and make sure it tells me it's a file. Type in this directory, make sure it tells me that that works, and then I'll type in something that doesn't exist and make sure that it can tell me that that works as well. I'll say, what did I called it exist.sh. Enter the name of a file or a directory. All right, so, exist.sh is a file, right? And we're actually running it right now. It's also a file. It's a script file. File. All right, great. If I run this again, and this time I'll enter the name of a directory. Test is the name of a directory that I have. You, of course, will have to enter whatever the name of a directory is that you have. And if you don't have one, you might have to make one first to test this out. It tells me it's a directory. And then if I run this one more time and I type in something that's not here, so just a bunch of random gibberish, it'll say it doesn't exist. Everybody with me? Cool. One more example for today. Reading in from files. Another very useful thing to be able to do. So our last script is going to be one that reads in information from a file. We'll type our directive for the last time today. We've typed it a lot today though. I'm actually going to use a while loop this time, which I know I haven't shown you a while loop before, but guess what? They work exactly the way that you think while loops work. They're while loops. They work similarly. But this is a little interesting and different. I'm going to say while read. We've seen the read command before. We've used the read command to read in whatever the user types in on the keyboard. Well, guess what? We're also going to use it to read in stuff from a file as well. The next thing that I'm going to say here is a variable name. So I'll say something like line, because it's going to read it in one line at a time. I'll say do. Down here, I'm just going to parrot, right? I'm just going to echo done. So this is pretty simple. I'm not doing a whole lot of work. But the next question that I need to think about is, how do I get contents from a file into this command? We've actually talked about that already. Does anybody remember how we get contents of a file into a command? Talked about it a week or so ago. Not quite. It starts with an R, the word I'm looking for. Could even give you a big old hint if I say that I need to use one of these guys, right? What are these called? Redirects. Redirects. So what I want to do when I run this is redirect the contents of a file into it. And so I'm just going to use one of my script files. It can be literally any file. I'll use one of my script files, and you can see that when I do that, it reads it in one line at a time and prints it out. So it read in the first line, printed it out, read in the second line, printed it out, read in the third line, printed it out, read in the fourth line, printed it out. In practice, you're probably going to want to do more than just printing, right? On the assignments, you're going to want to use that information to navigate navigate to particular directories and check to see if files exist and stuff like that. But this is how you're going to get that process started. So think about what that means. That means that the read command can be used to read in, keyboard input, but it can also be used to read in anything that is redirected into the command as well. Very powerful command. All right, we've got 10 minutes left, which is perfect because that gives me just enough time to kind of introduce the second homework assignment to you and chat about it a little bit. I believe it has already been posted on Canvas. So you should be able to take, oops, that's assignment 1. That's not the one I want to talk to you about. I need to go to the one that's due next week. That's still assignment 1. Here we go. All right. So there are 2 parts. The first part has you practicing Vim. This is where the very small portion. The second part is the majority of the assignment. This one should be very quick and easy. In my directory, the same directory you used on this homework assignment, I placed a file. I just put it there this morning. It's called Vim Practice. Please make a copy of that file. Please don't modify that file directly. Although that being said, it happens every semester. I understand. It's not a big deal. If you do it on accident, send me an email so that I can fix it as soon as possible and it doesn't mess everybody else up. That's one of the disadvantages of providing that file to everybody. But yeah, grab yourself a copy of that file, put it in the directory that you used for the last assignment, and work through it. It should be pretty self-explanatory. It should take you like 5 to 10 minutes. Just trying to get you some more practice using the Vim commands. The big part of this assignment is actually part 2. So that's the one where you're going to be writing a script, and the script that you're going to be writing is actually a script to grade the first homework assignment. So I'm asking you to write a script that's going to grade the first homework assignment. I'm not going to make you grade the actual first homework assignment. I'm going to do that, or my TAs will do that. I provided you with some fake information, some fake students, right? So you can grab that data set here. I'd actually like to do that real quick and show you what's in there real fast. So inside of these, you'll see that instead of actual students, actually I want to open this in the command line instead. I need to go to my downloads folder. Oh, that's fun. That's not what I wanted, sorry. Oh, that's so much stuff though. Oh my gosh. Okay. Struggling right now. Just want to show you these files real quick. That works. All right, cool. So inside, once you download these, you'll see that there are a bunch of directories for fake students who have been taking this class. They have done assignment 1. This is the folders that they created for assignment 1. So that means that they searched for their Wusto key inside of the .txt here, right? Hopefully they used the grep command like I expected you to use on the first homework assignment, right? To grab their string out of here, and then inside of these folders, you'll see that they have the password.txt file. So if I go into, I don't know. Yeah, so there's the password.txt file, right? And this is the one that this particular person found, which has their Wusto key right here. You can see, right? But actually, you'll notice that when you get going, that not everybody is going to have the correct stuff. So I think this one is wrong, right? So this one is not correct. They did not do the assignment correctly, and then some of them are going to be empty. I can't remember who has an empty directory. Batman did the assignment. Some of these are empty. Some of them don't have the file in there at all. Okay. So some of them have good information, some of them have bad information, some of them have no information. You need to give me a grade. There are 4 possible outcomes, right? 4 possible outcomes. They get a perfect grade if the file exists and has the correct information. You need to make sure that it's correct, which means you're going to have to look up their WSDL key in the big file and compare that against the content that they have in their password.txt file. Right? You have to run the command, make that comparison, see if it works or not. And then I'm asking you to generate a list of grades. I even tell you what the grades should be. So here's what the example output should look like. You can see that the 3 is the top mark that most people are getting. A few 1s and 2s in there, and even a couple of 0s. Iron Man and Superman didn't even make a directory, so they get no score, right? They didn't even try. So think about, and Lil Nas X actually did make a directory, but didn't make it right. That's why he got a 0, right? Because his WSDL key has dots in it, but he didn't make his folder the right way, so he should also get a 0 for not doing it right. I want you to write a script that's going to do this. So you'll have to use the techniques that we talked about in class today. In fact, I think that's another important point that I want to make clear. You can accomplish this assignment using what we talked about in class today. I don't want to discourage you from Googling and trying new things, right? But I know for a fact, because I've done it many times, I already have this script and I'm going to use it to create your assignment 1 very soon, right? I know you can do it using only the stuff we talked about today. It'll be a little bit bigger than the small examples we've talked about today. It'll be a little bit longer, but you can do it using only the stuff that we've talked about today. And if you, if I lost you at some point or you were confused about something, a particular example that I went through, I also want to make sure that you are aware that on the course calendar page, this guy right here, scripting.zip, I believe has copies of all of the examples that I went through today. So if you were able to get them down while I was typing, that's great. If you skipped one or got confused, you can go grab copies there. So a lot of times when people ask me for help on this assignment, that's my first recommendation. Go take a look at the examples, make sure you understand what they're doing, because that's the tools that I expect you to use to solve this part of the assignment. To submit this, you just upload your script to Canvas. We're not using repositories yet, but that's actually our next destination for next week, and I'm looking forward to talking to you about that. If you have questions about anything, I'll stick around for a few minutes. Otherwise, that's all I had for you for today. So have a great rest of your week. Have a great weekend. And I'll see you on Monday.